Hello, I'm Brian Farrell, and welcome to PACE IT session introducing network address translation. Today we're going to be talking about the purpose of network address translation, and then we're going to discuss how network address translation works. And with that, let's go ahead and begin this discussion. Of course, we're going to begin by talking about the purpose of network address translation. Network address translation, or NAT, solves a very serious problem of how to route non-routable IP addresses. As a partial effort to conserve the IPv4 address space, the private IPv4 addressing spaces were developed. These address spaces were removed from the public IPv4 address space and made non-routable across public IPv4 networks. And this led to the problem. Being non-routable prevents that private IPv4 address from communicating with remote public networks. NAT very simply solves this problem. A router with NAT enabled will translate a private IP address into a routable public IP address. When the response returns to the router, it passes the response back to the device that requested it. So now that we've covered the purpose, let's talk about how network address translation works. And first off, we get to talk about the fact that there are two categories of NAT. First up is static NAT. With static NAT, each private IP address is assigned to a specific routable public IP address. This relationship is kept and maintained by the NAT-enabled router. When a device needs access outside of the local network, the router translates the local IP address to the assigned public IP address. And when the response comes back, the router will translate the public IP address back into a local one. Static NAT is not flexible and leads to some scalability issues. An individual routable IP address must be kept for every device that requires access outside of the local network. So as the network grows, you need to increase the amount of public IP addresses that are under your control. That gets kind of expensive and kind of complicated. They developed dynamic NAT to resolve some of that issue. With dynamic NAT, the NAT-enabled router dynamically assigns a routable IP address to devices from a pool of available IP addresses. When a device needs access outside of the local network, the router performs the NAT function. Only the public IP address comes from a reusable pool of public IP addresses. That private IP address is assigned the public IP address from the pool, and once outside access is stopped, the routable IP address goes back into the pool to be reused. As initially designed, dynamic NAT was more flexible than static NAT, but it still led to some scalability issues. As more network traffic required access to outside networks, the pool of available public IP addresses needs to increase, or outside access cannot be achieved. But thankfully, there is a solution to this. And that solution is called port address translation, or in Cisco terms, that would be NAT with PAT. PAT is a type of dynamic NAT that was developed to increase the scalability of network address translation. When a local network device requires access to a public network, the NAT-enabled router dynamically assigns the public IP address to the device with the addition of dynamically assigning a port number to the end of the public IP address. The router tracks the IP addresses and port numbers to ensure that network traffic is routed to and from the proper devices. PAT still requires a pool of public IP addresses, but the pool may only contain one public IP address, or it may contain several for a large private network. This is the preferred method of implementing network address translation for two reasons. First off, there's less public IP addresses that are required, and it makes it easier for an administrator to maintain. Now let's talk about NAT terminology, specifically about the types of addresses. And we begin with the inside local address, which is a private IP address on the local network. It is the private IP address assigned to a specific device. Then there's the inside global address, a public address referencing an inside device. The inside global address is the public IP address assigned to the inside device by the NAT-enabled router, allowing access outside of the network. Then there's the outside global address, which is a public IP address referencing an outside device. It is the public IP address assigned to a device outside of the local network. Then there's the outside local address, which is a private IP address assigned to an outside device. This is the private IP address assigned to the outside device by the NAT-enabled router on the interior of the local network so that the inside device can communicate correctly with the outside device. Now that concludes this session on introducing network address translation. We talked about the purpose of network address translation, and then we talked about how network address translation works.